briefly touch on that because everybody's CI system is different, so I can't really come up with a generalized, like, it's good to run this. And then pricing and time for Q&A. So, why do we test? I mean, there are tons of reasons not to write tests, right? I mean, we don't have time, test is hard, Android test is even harder, iOS is even harder, but they're hard, so we don't write tests. But at least for myself, I want to be a better developer, so like writing tests is like one step toward that direction. That's my opinion. You can have a different one, but it's okay. So suppose you have Android app, and have you ever wondered like what's in Android test directory under the source and the test directory under the source? I see a lot of open source Android apps on GitHub that has those two directories empty, or not empty, but with application test and example unit test in them, because that's what the IDE generates, and people doesn't even care to delete them, so it's there. But if you don't have them, you can create them and like basically create them in the location that's like under Android test / Java or test / Java. So for Android test, that's where your instrumentation tests go, and for test, that's where your JVM unit tests go. What's the difference between those two? Oh, sorry, before that. You need to add dependencies to your build.gradle file, otherwise they won't run, because you need to add them. You need to add test compile JUnit 4.12. That's the version of JUnit 4. And then Android test compile tells the Android Gradle plugin, like, this is what we're going to use to run our Android instrumentation tests. You can get more info at the ATSL Android Test Support Library website. I have a link at the end of the talk. And so back to the topic on JUnit versus instrumentation test. JUnit test is anything that doesn't touch Android. So your probably business logic that doesn't have anything to do with Android. But for like UI test or some tests that needs to deal with anything that has context in Android, you have to use instrumentation test. Of course, you can use RoboElectric, which is basically mocking everything out and run that on your JVM locally. But it breaks after every Android test tools update. So it's probably, to me, it didn't worth my time. So that's why I didn't like put RoboElectric in here. But anyway, so JUnit test for tests that doesn't touch Android, and instrumentation runs, and to run instrumentation tests, you have to run them in like emulator or on a real device. So here's an example of Android UI test. So you can see a public class main test activity, main activity test, and has a test rule, and tests are marked with the test annotation. I mean, this is just like a JUnit 4 test, regular JUnit 4 test. So it's not like, oh, you have to extend activity test case to like before. They basically moved to this probably 2 years ago. So it's been much easier to write tests because, anyway, I'm not talking about how to write tests. I mean, how to write tests is not the main topic here, so I'm running through this quickly. So to run the test, you basically right-click on the test class on the Android Studio project view, or in the source code. In the source code, you can also right-click or Shift F10 to run either the whole test suite, like if you right-click there, or if you want to run an individual test method, then you run on that thing. And you can always hit play to rerun the test, because when you are actually writing a test, you probably will iterate it over and over and over. Actually, it's not really writing the test. Once you have the test written and you're writing your code, you're going to iterate it over and over. So that play button will change into like run your test instead of run your app. So say we want to write a simple test for a very simple app that only shows hello world. So in order to check if hello world is on the screen, we can use Espresso, which is a UI testing framework for Android. Say on a view that has this text string, string.hello, we want to check if the state matches is displayed. So that's the like syntax of Espresso. It will feel weird at first, but once you get used to it, it's like talking in English, probably. I'm not a native speaker, so my intuition of like English is probably off. But that's basically the test to check if hello world is on screen. So now your PM comes to you and says, hey, we need to implement a new feature. I want the text to change when the user taps the fab. Fab is that, somehow it's a mail icon, but anyway, that's the fab button. So the PM said, I want to be able to change to, once I press the fab, the text should change. So this is the modify test. We first make sure, on the first line, we first make sure the text is hello world, and then on the second line, we look for the button with ID fab and check if it's displayed. If it is, then we perform an action called click. And once that's done, we want to check if the text in that text view becomes modified text. And of course, it fails. Why? Because you haven't write the code. Because it's hard to actually like demo that, so I'm going to show you a video. So on click is where the fab is clicked. So we just change it to set text to modify text. And we run it. We come back to the test and run it, and you see Android Studio like running, installing APK, running the test, and it should pass, right? Nope. Why? Because it's capital M, capital T. And our test case is lowercase t, m, and t, so it failed. And now we change the test case, and it should pass. Yes, it passed. So that's how you write a test, update your requirement, update your test, update your code. Simple. So is this helpful? To me, it is. It has some benefits, like faster turnaround time for like a bug, because once you capture a reproduction step in a test case, then you can run through it without having to go to your device and navigate. So that saves a lot of time. You can catch bug if your test coverage is pretty good, but at first it's going to be spotty. And the last one is, because you're designing, in order to make your app or your library or whatever testable, it will have to be like chopped down to smaller independent units. So with that, it can actually help you like limit the scope of change when you are actually doing it, and that will also help you speed up the iteration. So this is basically just a segue into our main topic today. I'm not going to take any question. You can ask me at the end. So assume that I convinced you to write some tests. Now you have a lot of tests. Actually, after about 100 UI tests, it will start to feel slow. So one solution is, of course, let somebody run the test. But if you're like me, I don't have QA, I can't have somebody run my test. I don't want the test running on my machine. Then emulator in the cloud can help. And another question or another problem that we app developer face is supporting multiple devices, especially on Android. iOS developers are starting to see this because Apple is like introducing weird screen sizes now. but Android has been, I don't know, 40, 50,000 different type of devices. So you have more users, which is a good thing, but they have different devices, that's not so good. But come on, we don't want everyone to be using Samsungs, right? So, so in order to deal with like too many device problem, you can harness the device farms out there on the internet that provides you real device access. So for emulators, Firebase Test Lab has it. And also for real devices, Firebase Test Lab and AWS Device Farm also have it. Now, before I move to the two like cloud solutions, some of you might actually have your own cloud already. Right? You might have your CI hosted, or you might have your internal CI like farming out to AWS or Azure or whatever. And why can't you use your own CI? I mean, sure, you can. The one problem is, well, there are a few problems. One, no real device support. You can only run emulators. And two, emulators on AWS is slow like crazy. For an ARM emulator, starting up is, I mean, API 15, not API 22. So API 15 is my lowest supported device. An API 15 emulator starts at 150 seconds. That's probably longer than what your test net will actually take. So it's slow. And maintaining the whole testing infrastructure is probably a full-time job because it's brittle. And if you write your test on your like beefy laptop, and expect it to run in the slow emulator on the cloud, you're wrong. It's completely different. So sometimes it skews your results by like way too much that you have to kill the test. So I am not going back to like emulator on my CI. But of course, there are pros. A, you can control how to run the test because it's your own CI, because it's how you decide to start emulator, how many of them, how to like shard them, like you have control over that. Like I love to use Square Spoon library to drive my Android test because it gives me like beautiful HTML result patch, but I mean, it doesn't really matter if your test is failing like here and left and right, because your test is not giving you the results you want, then having pretty HTML report doesn't really help. And another pro for doing it on your local or your own CI is it's probably cheaper. I put that in quotes because you have to do your own math. I mean, my math is probably different from yours. So in my case, it's not cheaper, but it might be in your case because you are better, you work better than I do. So we got things done in shorter time. That's why it's cheaper. So Firebase Test Lab is an offering from Google. They only support Android and real devices in racks and racks and racks in Google's data centers. So these are pictures I took when I was Google I/O last year. They actually like rolled one of the racks out to Google I/O to let people like take a peek. So you can see like phones, tablets in those racks. They provide real devices and emulators. The other one I'm talking about is AWS Device Farm, which is a company that got acquired by Amazon. They support both Android and iOS, and they support change device state. Firebase Test Lab doesn't support that. You'll see in the demo soon. And then they also allow remote access to device, so that might prove to be useful, depending on how you want to use it. I never used that, so I don't know, but it's a good feature. So in order to run your test on them, you have to, of course, send your test APK to them. There are different ways to do it. For both, so both Firebase and AWS have a web portal. You can upload your APK there and then check some checkbox and set stuff. So I'll demo that. And then there's also CLI, command line interfaces for both Firebase and AWS. And the last one is run the test directly from Android Studio. It's only supported by Firebase for obvious reasons. So I'll demo them as well. So let's get to the demo. Let's see. So can you see this? Let's see if I have internet access. Yes, I do. Okay. So when this is the Firebase test lab console in the Google Cloud Console. You might want to ask me, why is Firebase in Google Cloud Console? Because this thing started out as part of Google Cloud's offering, and then somehow they like slice and dice different products out. So it's still on Google Cloud, but it's Firebase. It's weird, but like all product Google, it's weird. So this is test lab for Android. So you can have different test projects, and then of course I don't want to use dummy in my demo. So this is one of my like running tests in my own account and run like some pretty stupid instrumentation tests. But to run a test, you say I want to run an instrumentation test. So the robo test is like randomly taking stuff, but with some intelligence. So it can actually recognize login and type something in, and then start randomly like bashing in your app. So that's for people who doesn't even have test coverage. That's at least something, and that's actually what they offer in Google Play Console when you submit something. So when you publish a new revision of your app, they run through these. So you can actually see like test results. I should add those in my slide. But so say we want to run an instrumentation test. So 2 steps. One, select the app, and so I want to submit my app debug.apk and my app debug entry test.apk. And if you are writing a library, then you don't have an app APK, so you'll have to use the same test APK in both app and test. So now, the second step is select dimensions. What dimension means is the device, OS, and orientation combination. So for example, in here, this is a list of physical devices that are available, like Nexus 7, HTC One, LG, so I changed the result. And then Moto E, Moto G, and G4, and different API versions, like Galaxy S7 only have 22 and 24 because it's a relatively new device. So the list here is probably more than what you have in your own device lab. But note one thing that's missing, well, not just one, but it's missing things that are lower than API 19. So if you need to support API 15, 16, 17, 18, you're out of luck here. And then there are also virtual device offerings. So again, starting from API 19. But I mean, this is so why do we want to use virtual devices? Because they're actually more stable than physical devices, in my experience. Because on physical devices, even if you can afford wiping everything out and like automatically set it up, sometimes it will still behave differently from AOSP. And these virtual devices are basically AOSP with some modification, but that's probably not. You probably won't see it as an app developer. And then you can also change the orientation. And basically, if you click start, you will start running the test. And maybe I'll click it. This is my personal account. It actually costs money. So do it. You do it using your company account. So we basically submitted a test that runs on 8 different configurations. Nexus 5 from API 19 to 22, portrait and landscape as well. So actually API 19 to 23, so that's 8 of them. Because they claim they will support more locales, but not yet. So once locale is added, there will be another dimension to it. But come on, who doesn't use English, right? So that's the submitting test via the web portion. Now, if we want to submit the test in Android Studio, this is presentation mode. So we can say right click. On Mac, you can probably control click or something like that. And then select run tests in blah. And voila, cloud testing tab. Come on, it's right in Android Studio. So there's no reason that you don't use it other than price. But if you sign up for like the basic plan, you can actually run 10 tests a day for free. So it's something you might want to consider. And basically, you can create different matrices of devices in Android Studio as well. The layout is all messed up. I probably need to file a bug. But you can, again, select devices, select versions, select locale, select orientation. And then once you say OK, you will submit the test and run the test like this. So for those of you who actually write tests and run tests, this looks familiar, right? I mean, this is basically what you see when you run local tests. All the test cases, if they pass, if they fail, and console messages and all that is similar to what you'll see on a local running test. The only difference is if you run, well, no matter where you run, like physical device or virtual device, there will be startup delays. So, so this is not something you will do like while you iterate through your daily development cycle. It's probably like before lunch. Okay, I'll test what I did in the morning, and probably before you leave. Probably not before you leave. Probably an hour before you leave, so you have time to fix bugs. But come on, we all want to get off work on time, right? So that's the demo for submitting via web and Android Studio. And command line, because this is part of Google Cloud, so it used the G Cloud utility to submit the test. But they made some progress. Before it's G Cloud Beta test Android run. Now it's called G Cloud Firebase test run. So it has Firebase in there. So it's no longer that disconnected. And basically you can specify type, instrumentation, or robo, and then your path to your app, your path to your test APK, device IDs. You can query a list of device IDs. I'll show that in a minute. And then you can specify one to run on OS versions 19, 21, 23. Don't ask me why I skipped even numbers. And different locales. I did this talk in March back in Taiwan, so there's ZHTW locale, which doesn't exist. And then orientation, portrait, landscape. So for devices that doesn't support certain OS versions, they'll just skip it. They'll just ignore those combinations. Same for locales. If locale doesn't exist for a certain device, then it'll be skipped. This will create a matrix of 12 tests. So be careful when you do this. Well, it's okay if you're on company money. So, so this is a command line output. So you can see creating individual test executions, test results will be streamed to blah, and then run something, run the instrumentation test using Android JUnit runner, Instrumentation test complete details are there, and then a table of like what's done. And a list of current models. Maybe I should do it here, not there. This? No, sorry. Too many windows. Anyway, so it's G cloud, Firebase, test, Android, and probably call this device or something like that. Here. Models. What? List. So you see it has like real device, physical device, virtual device. So these are the device ID that you need to use when like specifying what model to run the test. Like for example, if you wanted to run it on Nexus 5, physical Nexus 5 is actually Hammerhead, not Nexus 5. So before you like write your CLI script to run the test, you probably want to first list what the models are there, and then pick the ones that you actually want to test. Like, do they have a Galaxy S3? Yes. An M0, that's a Galaxy S3. I hate Galaxy S3, but that's why we need to test. And you'll be surprised how many users are still stuck on S3, Galaxy S3. Where's my? I'm serious. I had to tell one of our customers to block all Galaxy S3 variants because I don't want to support it. So that's for Firebase. Any questions so far? Yes, ma'am.
Where do you, here's my Android project, and this is the Firebase project, so that would be mine, whatever it's tied to that particular project.
So for Firebase, you create a Firebase project on the console, and then when you do G-Cloud setup, you can basically use the credential for that particular project. I basically have a project created on Firebase that I use, and basically set that in my G-Cloud setup. So you have to do that. So you can't really sign up for Firebase Test Lab on Google Cloud. You have to go to Firebase. Yes, sir.
As far as the virtual devices, are those all with Google Play services pre-installed, like Google Maps and things like that, you know?
Good question. I forgot, but
Okay.
probably.
I don't see anything right on it, at least in the list.
And on the list here, one thing I want to point out is this. Nexus low-res, generic low-res, no resolution NDPI device. That can be very useful actually, because it runs tests so fast. I'm serious. It's fast. It starts up fast. It runs your test fast. If your app is not like layout for tablets, it can usually run your test fine. But of course, if you deal with like lists and stuff, you probably need to make sure your code actually like scrolls one by one until you find something. But that's basically what we have to do to deal with multiple device screen sizes anyway. So if you write your test correctly, use that low-res device is actually pretty helpful. So, yes, sir.
Can you run a robot test?
Yes, you can. So in here, when we do Firebase test, you see in the type, you can actually say robot instead of implementation, and then you don't have to specify the test APK. But I don't know how to tell robotest what to use for authentication, so you might have to look that up. Yeah, but that can be a first step in having some test coverage. But sometimes that actually drives you crazy. Should I move on? Okay, to AWS. Who uses Amazon Web Services? I'm surprised not that many. Who uses Azure? Who doesn't use any web service, any like cloud infrastructure at all? Okay, 1, 2, then Where else are you guys using? Google Cloud? I am a GDG organizer, and I don't see that many people use Google Cloud computing stuff. Anyway, they gotta put more effort into like selling a product. So
All the effort.
that's true, and their engineer probably do 3 engineering jobs.
We have a cloud event this Saturday.
Yes. So if you don't mind seeing me again, you can come to our event on Saturday. So AWS, I forgot to put device farm, but this is AWS device farm. It was Abstract, which got bought by Amazon, and so it's part of Amazon now. It provides web and Gradle plugin. I'll demo the web first. So this is what you see when you come to device package. Now, this is what you see when you come into device farm. You can create a new project for your project, and then I will use this simple app. And this is what you see when you come in. Like your old tests are here, and you create a new run. So in Firebase, it's called a new matrix or something. This is called a new run, and then first you pick Android iOS or HTML5 app. So that's different from Firebase. And then, of course, again, I'll upload my implementation test. One thing I don't like about this is I have to give it a name. I'm bad at naming, so I'll just say 1, 2, 3. Okay, whatever. And then configure a test. So here are some different types, like Explorer. That's like the robo test with authentication. So you can actually tell it to use certain username and password, and then you'll just look at buttons, click, and like come back, like the monkey. Not sure for us. They also support Appium. I don't use, so I can't really demo, and I can't tell you what it used. And Calabash. It's also a pretty famous testing framework. I don't use it either. Instrumentation and UI and Automator. I thought UI and Automator should be merged into instrumentation, but anyway, so again, because we want to run an instrumentation test, I'll use my Android test APK. And one good thing is it has test filter. So, like for example, if you have a test APK that contains tons of tests, you can have a filter to let it only run certain subset of your tests. Because, for example, if, say, your camera doesn't work on Galaxy S5 only, well, then I'll just run those tests on Galaxy S5 instead of run all of them, because running these costs money, even if you are on company income. So then you have to pick a device pool, which is like the matrix in Firebase. So let's see, what do they offer? Is the phone big enough? Of course, 5 tablets. It's Amazon after all. But look at how many Galaxy tabs they have, like different variants. I mean, that's why I don't like to test on Sentinel devices. They have too many variants of the same name, but they all act differently. So they got some Sony. Who uses Sony? Yay! And some Wiko whatever. I mean, they probably found it on some shitty seller on Amazon or something. Bought a ton of them and put that in their brands, maybe. Hey, BlackBerry. So you see, their device coverage is probably better than Firebase, probably because they started earlier, and they also support iOS. So if your shop has both iOS and Android, you might want to consider this. I'm going to use a smaller device pool, which I created. Of course, a Sony device and a Samsung device. And next, you can actually say, what extra data you want to be present on the device. Like for example, you can upload photos, you can upload app data or a SQLite DB, whatever, to initialize your app to a certain state. And it also supports installing another app, so your app can talk to it. I have never used that usage, so I don't know. I'm waiting for someone to do a talk on this. Then you can check the radio state if you want Wi-Fi, if you want whatever. Device location, so you can probably simulate like in the middle of Sahara with what's like edge bad or something like that, edge lossy, to see how bad your app performs under bad network condition. That's my problem. And next step is actually pick a timeout. So the wizard is so much more verbose on AWS because probably they got more complaints. And so I just say, let it run for at most 5 minutes because sometimes your test stuck. And start up. Another billable hour. So this is basically, oh, what? It failed already? No, this is an old test. So see, once you submit a test, it will start like spinning there. It will take some time. So let's come back to our slides. On the web, that was how you like run a test on the web. So it's kind of okay, but as a programmer or developer, we are lazy. Clicking so many clicks is hard. So let's do it on the command line. Can you see this thingy? Basically, Gradle device check, and that's it. You will then submit your project to whatever you specify in your build.gradle. So you specify the device pool, you specify your test filters, and it will be run directly from the command line. So one downside is it's run asynchronously. So if I hit this, and it will start building stuff, and then it will say, uploading APK to Amazon, running your test, and go see this web page for update. Not useful for CI. I mean, I needed to like stay there and come back with an error code, not just like leave me with a URL. But that's what they do. That's what they have right now. So that's basically AWS. But at least you can run it using command line. You don't have to click that many clicks, and you don't have to like write a script to run the Firebase test lab. I mean, I'm pretty sure you'll put that in a script, not typing it out every time, right? That's the what did I do? That's the submitting test portion of your workflow. Getting them back, well, both of them supports getting the results on the web for sure, and then they also provide instrumentation test results. However, only Firebase provides XUnit or JUnit XML format because, I don't know, somehow AWS doesn't have it. So JUnit XML is convenient if your CI or something has like JUnit XML parser that shows you like pretty graph of test pass, test fail, test runs. So if your existing tool uses that, you probably want to consider Firebase. But if you have tool that actually parses instrumentation test output, then both services will work fine. So in Firebase, and in Android Studio, I mean, we saw the result was just right there. And then on the web, let's go to here. So on the web, you basically click on one of the runs, and you will see, like, okay, I run these tests on one device. This is something I ran 4 hours ago. On one device with these test cases, and here are the logs And of course, everybody loves video, so they provide a video with a frame rate of 1 per second. So if you're testing animation, it's probably not going to help, but this is helpful for like a general test flow of things. The test is pretty stupid, and it's like repeated 4 times, so yeah, the video won't tell you anything useful in this case, but in your real test, like the test cases I have at work was probably 400 UI tests or something like that, or Cooper. And videos actually help. But you will ask, where do I get the raw test results, like your logcat, your instrumentation test result and stuff? You have to use that view source thingy and go to a bucket on Google Cloud Storage. So you have to use another tool to grab the file from command line. And then you see like bug report, instrumentation result, logcat, and your XUnit result file. So that's what you get from the web. And for command line, you have to use Google Cloud or Google Storage utility, not G-Cloud. I don't know why they're 2 separate utility. I mean, you can, like AWS have AWS CLI that talks to all their service. I don't know why we can't have one. But you basically use this syntax, CP and GS is Google Storage, and then the bucket name, which you have to parse from some output. And then if you want the test result, you can do like test result .xml. One of the problem people have in integrating this in CI is actually parsing out the bucket names. So there's an option in Google G Cloud that specify a bucket name. So you can probably specify a different bucket name every time, and then use basically keep like a variable in your script for bucket name, and then use the same bucket name later when you want to grab the files. That's just for CI. For command line, you have to use gsutil ls, look for the bucket and look for the run. And so this is where like a lot, I mean, we can demand more change if we actually use them. So getting results from command line is not optimal. On the AWS, if I use not optimal on the previous one, this one is probably even less optimal, because you have to list project to get your project APN, which won't change. So then you need to list runs, because, for example, in my AWS console, I have just this many runs. And if I run AWS and this, I'll just copy from my cheat sheet. So say if I say list runs for my project, you will see gobbledygoo of JSON that lists all the runs you have. And then you of course have to parse it, get the APN, get the ARN out from one of the runs to list your artifacts. And then once you list the artifact, let me run that.